All right, let's get started. So today we're going to go through all the environment software packages that we're going to need for the course. And we're going to go through the step how to download them and how to install them. I also sent an email yesterday about the account. So all have your account now? If not, let me know. Okay, we need to have that probably maybe on Friday. We will not use it today. So, but today is just going to show you how to install the packages and some of the concepts about package management and how to install packages. That's it. So here, if you go to the website and then resources, and then click software. So here are some of the things we're going to go through today. And so this course, we are going to use a couple of software packages. So the first one is Conda. Okay, so Conda is a package manager, and you can get that by through installing Miniconda or Anaconda. Either one is fine. So all the lab computers should already have Anaconda pre-installed. But I'm going to show you anyway how to install that if you want to put it on your personal computer. And the second one is Visual Studio Code. So that's basically called an IDE, okay, integrated development environment. So basically, you can think about some software package you can use to write code, just like Microsoft Word document, like you can use to write anything. So this is for writing code. Of course, there are some other alternative out there. For example, Python, and or you can just use Notepad. So Python script is actually a plain text document, so you can use txt Notepad to write document. But usually we don't do that because there's no auto completion and there's no syntax checking, so it's going to be very difficult. But I'm just saying it's possible. You can open any Python script using just a Notepad. And the last one I'm going to use is Git. So Git is a version control system. So basically, you can use to keep track of what changes have you made to the package, to the source code, and you can also allow people to collaborate. So you can also work together on the same project, and people can submit so-called pull requests, basically contribute to the repository, and then you can merge together. We'll show you some example probably maybe on Wednesday. Today we will not go through that, but we just install the software. Then on Wednesday we show you how to maybe use GitHub and how to have some how to contribute, for example, to open source. And this is very important because these three in here, if you want to work for tech company, most likely these are going to use you want to use daily. And we're going to go through how to set it up. And so the first one here, as I mentioned, is called Conda. If you go to, for example, on Windows, on the lab computer, it might probably already have. So if you go to new all apps, and then there should be one here, Anaconda 3. And this one actually installed using Miniconda. So you probably, I only have 2 items. If you go to the lab computer, probably you have more. And so for those of you who have already installed this before, you don't need to reinstall it. But I'm just for all those that have not used this one before, then we need to install that. So here you see I already installed. So it's Anaconda PowerShell prompt, and there's another one, Anaconda prompt. So you will see here Miniconda. If you install Anaconda, you probably have more items on the menu. That's fine. But all I need is this one, Anaconda prompt. If you click and open it, it will just looks like a command prompt. If you're on Mac computer, you can probably just type terminal. On Windows, it's just the Anaconda prompt. And this is what it looks like. It's not fancy, but this allows you to install packages. I will show you later. So for now, let me show you how to download the software. If you already installed Anaconda, perfectly fine. So this here is a Miniconda, Anaconda. So Anaconda, you can think about is just like a large package that contains everything. And most of the time, we don't need everything. We just need a small subset of what we want. Because Anaconda, this one is pretty big, so it's going to install several gigabytes on your computer. Miniconda is only, I think, 60, 70 megabytes, so it's pretty small. And I would recommend that you just install Miniconda if you have not used it before. So I'm just going to open here and then show you the website. And these are all the links. So of course, find the one that works for your operating system. And for nowadays, you probably want the 64-bit. Don't use the 32. So just click this one and then just download it, save to your computer. Then you can open your File Explorer. Then you can just double click to install it. It should be pretty straightforward. If you have not used it before, let me see if you can. When you here, I already installed it, so the interface sometimes might look different. So I'm going to click next, agree, and here you can just click just me, just all the default settings, and then the last one here is going to install under your user directory. See users, and then your name, and then Miniconda suite. If you click next, it should just install to your user directory, and then I can find it somewhere here. Go to my, for example, my account, and then see users under your name, and you should be able to find somewhere here. Let me see here, Miniconda suite. Here, it's going to install things to your computer. So it will just be a directory on your computer, and then once it's installed, then you should be able to find it under your apps, and then the start menu, Anaconda suite. And if you open this one, you just look like that. I just showed you before. Then you can just maybe right click and then ping this one to the taskbar, so that you don't need to go to the start menu all the time. And when it's open, you're going to see here on the left side, you should see the parentheses space. So that means right now you are within the Conda. If you just open the traditional terminal, it will look like this. So let me show you here. Maybe I just show you this one. Terminal. It might be the same. I'm not quite sure here. So this is called PowerShell. Okay, it's automatic because I already used that as a default. But when you open that on your computer, if it doesn't see the base, that's fine. You can always open Anaconda prompt by going to the start menu and then going to all apps and then open this one. So this is probably just similar to the traditional command prompt. The only difference is right now we are within the Conda. So you can create new environment, you can install packages. And let me give you an analogy why we want to use this one. Because when you're doing software development, sometimes you need packages of a specific version, right? So think about ArcGIS, right? We have ArcGIS Pro. We used to have ArcGIS 10.6, 10.7, 10.8. You cannot have the same. You cannot have 10.7 and 10.8 on the same computer. If you install another one, you need to uninstall the other one, right? But in the software development, there are people, you are trying to develop something that can be used by everyone, right? So you don't want to like, okay, I give you this package. You need to use ArcGIS 10.8. You need to use the latest version. People might not be able to do that. So software development is very important that your package can work across platform and also across multiple versions, right? For example, I'm developing a package. You can use it on Linux, on Mac, on Windows. You don't want to develop packages that specifically you can only use on Mac. Of course, sometimes there are limitations that will exist, but most likely for Python, you want to develop something that you can use anywhere on any operating system, and also for any Python version. Okay, so in the past we have Python 2.7, but this has been deprecated. So don't use Python 2.7 anymore because I think it will reach the end of life later this year. And after that, there will be no support. So if there's any bug or anything, they are not going to fix that. Kind of like ArcMap right now. ArcGIS Desktop is going away. Probably this year will be the last year they're going to provide updates. And after that, they are trying to switch to ArcGIS Pro. So you have to like do everything within ArcGIS Pro. That's the recommended way. Similarly here, you want to use Python 3 point something. And sorry, Python 2.7 has been deprecated for a long time. I mean, years now. I'm talking about Python 3.7. Python 3.7 has been is not going to receive update, I think, later after this year. So we should have used the minimum Python 3.8. And so 3.8, 3.9, 3.10, 3.11. I think I'm not sure if 3.12 has been released or not. But use anything between 3.8 to 3.11. And as you can see, right, we have different versions. Sometimes when you develop packages, you want to test on multiple environments, right? If you're using ArcGIS Desktop, you probably need to have another computer to have a different version so they can test it, right? But it's not going to happen like you are different packages for so many versions, so many operating systems. So you want to have something that you can test it on your computer, but it's going to maybe work across platforms. And later on, I can also show you how you can use, for example, GitHub to test on, even if you don't have a Mac computer, you can test your packages on a Mac operating system just using a computer or using cloud environment. So the Conda package management allows you to create virtual environment that you can install different versions. So each environment is an isolated one that you can install anything. It doesn't affect other environment outside. Okay, so this is the goal of using the Conda package management. If you use ArcGIS before, it will actually also install Python, I think 2 point something in the past, like on your computer. So if I go here, let me see if it's still here. For example, this one, Python 2.7. So this one comes with ArcGIS Desktop. And nowadays, they've come with Python 3.10. This for ArcGIS Pro. And this is more like system Python 3.10. But you don't want to use this one, because if you install something to this Python 3.10 here, it might accidentally break something, because ArcGIS is very specific about the package versions that they're going to use. If you update something, it breaks, and then your ArcGIS Pro will break. Not ArcGIS Pro, but your ArcGIS Pro, the Python interpreter will break, and you cannot use the ArcPy packages anymore. So don't try to touch this one. We're gonna just use Conda, and it's isolated. You can do whatever you want inside. Once it's done, you can delete it, you can clean it up, and it doesn't affect your outside operating system. Understand? Think about here in this building, right? Each room has its specific functionality. So what you want is to do something within the room, and then you can clean up, you can rearrange, you can do whatever you want. And after you're done, you can clean up and destroy it and create a brand new fresh one. So this is the power of this one. It's very useful, especially for software. Sometimes it's going to happen during your coding journey, is that you install some packages, and then later on you install additional one, and then the environment breaks. Your map doesn't show up anymore, or something doesn't work. Then you can easily delete the environment, create a brand new one. It will just work. Okay, just like you on your Windows, you install a bunch of stuff, and sometimes you install some additional packages that you have virus or whatever. It's just something just doesn't work anymore. You can easily in the Python Conda, you can recreate one, but for Windows, you need to reinstall the system. It's going to take some time, but this is the one that's very useful. So, and I'm going to show you how you can do that. Here, I have some commands in here. So Conda commands. So these are some of the commonly used commands that you don't have to remember all of them, but these are the common ones that if you remember them, it's going to make your life much easier. So I'm going to show you how to create a new environment and how to install packages. Think about you're getting your new iPhone, right? You're trying to install packages. What do? You go to App Store, right? Simple. Same idea in here. In for Python, there are different repositories that you can use to search packages. And there are tons of things out there. They're like, not million, but tens of thousands of packages available on the internet. It's all free. So these are the 3 websites where you can search for Python packages. So the first one here is called PiPi. If you open it, so this is PiPi stands for Python Package Index. So basically, just like this is the App Store. You can use to find packages. You can install packages. So here, In this course, for example, we're going to use geemap. So if you just type geemap, and you can show up here, anything related to that keyword that you're searching, you'll be able to find it. And you can just click any one. So for example, geemap right now is 0.25.0. So most of the packages online, the version is not always the case, but the convention is to use 3 digits separated by dots. So the first one is the major version, the second one is the minor, and the last digit is the page. So major, minor, page, and this is usually the case. So page usually there's a bug in the software. You fix it, you release a new version. The second version, for example, next time I might release 0.26. Usually this is where you add some new functionality and it doesn't have any breaking changes. There's usually you bump, so it's basically called bump the version, increase from 25 to 26. And the first digit right now is still I can use like 1.0 or something. Major version usually means you introduce some new functionalities. There's no backward compatibility. That means it breaks something. Usually you want to indicate. Also on the left side here, you can look at the release history. So if you click the release history, you will see the pattern in here, right? So for example, 0.24.0 and then 0.1, 0.2, 0.3, 0.4. Of course, you can all the way to 0.5, 0.6, but sometimes you have some new features, and then you think it's going to make a new minor release. Then you can increase the second number, and probably in the next couple of months, we have 1.0, 1 point something. So this is, you can look at the history, right? So every couple of weeks, I release a new version, and this is a long list since I think 2020. So it's more than 3 years ago. And it's increased a lot. So there are a lot of things, new features being added to the package. And lastly, you can look at the download files. This is where you actually look at the source code. So for the downloaded file, we have two versions: source distribution and also the build distribution. This one means you can already compile. You don't need to compile the source code. But for this one, if you click, you will download the source code to your computer. But you don't need to. I'm just showing you, if you sometimes you want to inspect the source code of a package, you can do that. So if I click and then open, and then I can show you what it looks like. So if I open the file, and we're looking into. So this is basically when you install a package, it's actually going to download this zip file and then install on your computer. I'm just showing you manually, but later I will show you how you can install easily. So these are all the source code that is being installed to your computer when it's installed. Lastly, look at this one. Pip install geemap, and there's a button here you can click. So all the Python packages, any packages that appear here can be just pip install. So pip is actually like a program that you can use to install packages. And I will show you after you create the Conda environment, I'll show you how to do that. So this is the first official repository that you can find packages. You can pretty much find anything. So if you're doing machine learning, for example, you can just type, for example, scikit. Okay, so scikit-learn. There are lots of scikit packages they use to do, for example, machine learning. And anyone can publish packages in here. Anyone. So I have another course, 510, software design, actually teach how to publish packages in here. That's not the focus, but I'm showing you that anyone can publish something here. And because anyone can do something, there is sometimes have some side effects. People can put malware in there. It happens. Although sometimes people report they will remove that, but just to let you know, because of this one, there is no quality control on this here. And I would maybe treat this one just like we have Apple App Store, and in the past there's also jailbreak, like what's they called, DD or something, like you can install some software into your iPhone. Basically, nowadays we don't hear that all the time, but maybe a decade ago, a couple of years ago, they're still very popular because iPhone is very restricted about what software you can install. So people basically relax the admin right, and then allows you to install packages from somewhere else. It's not always safe, but this is basically anyone can put stuff out there. Okay, and the second one is called Anaconda package repository. So if you open it, this one here is quality control. So this one basically a much higher quality, and you will see the number, the number of packages is much smaller than the PiPi. PiPi, I think maybe tens of thousands, maybe over 1 million, but this one is a much smaller number. It's quality control, and also it's better because it's more likely going to work across platform compared to the PiPi. Package from PiPi sometimes only work on Windows or on Mac. It doesn't work on Linux. There's some compatibility issue, but Anaconda here, some of the packages have been pre-built so that you don't have to compile them on a specific computer system. And similarly, on the search box here, I can search just geemap just to show you. You can search any packages in here, and then here shows you where it is. How many downloads? For example, 194,000 downloads so far. And you can click here just to show you, the second one. And it comes from Conda Force. I'm going to show you here. If you click this one, also you should be able to see the command here, Conda install -c Conda Force and then geemap. So these are the two ways you can install packages. The first one is using pip install. The second one is using Conda install. Most of the time we want to use Conda. You don't want to use pip, although it doesn't prevent you from doing that. But you don't want to mix the packages, because packages you want to come from the same channel. And one nice thing about Conda is that it makes sure that the packages are compatible. For pip, you will install whatever package you ask it to install. It doesn't track whether it works or not for other packages. Because, for example, for me, let's say, okay, I want ArcGIS 10.8. The other package want ArcGIS 10.7. You want ArcGIS 10.6. And if you install the package, it doesn't care. It will just install things to you. And then even if those two packages have conflict, it's going to show you a warning, but it doesn't actually fix the problem. Conda will actually tell you that if you're trying to install this one, for example, that package requires Python 3.10. Right now you have a package that requires Python 3.8. You will install it anyway. So you basically pip will most likely break your environment. So you don't want to do that. You want to be consistent. Unless a package is not available on Conda first, then forget about it. You have to install using pip. But come here to search first. If it's available, install from Conda. And that's the recommended way. And the last one is Conda Force. Anaconda and Conda Force. So you can think about Anaconda, you can search all the packages available on Conda Force, but also Anaconda maintains its own packages. Kind of like Apple, iPhone, right? Anaconda is more like the Apple. And it manages all the packages, and including, Conda Force, you can search the packages through here. But Anaconda comes with its own, some of the packages that it maintains. So again, that's all quality control. So recommended way, you want to select packages from Anaconda or Conda Force. And if the data is not available, then you use PiPi. So that's the way you find packages. Next, let's talk about how we can install them. Okay, like I said, you need to open Anaconda prompt. And when it opens up, if on the left side you see the parentheses base, that's good. Means right now you're within the Conda environment. So think about when you install something, this is the base environment, but you don't want to install things to here, because if you break the base environment, the entire Anaconda or the Miniconda is broken. So this is what I mentioned earlier. Very important that we want to create virtual environment. Virtual environment means that it's virtual. Whatever you do inside, it doesn't affect the outside. Okay, just like in here, you get this building, you want to get into this building, do something, you want to do within a room rather than doing outside the hallway, because if something is broken, the entire building, you cannot have access. So what we are doing in here, let me show you. Usually the first step you want to check is what kind of environment are already in there. So here you have on the left side here, Conda env list is to see if there's already something in here. Just like in this building, you just want to see how many rooms in there. What's the name of the room? So you can just conda env list. Just type it. You're gonna take a couple seconds, and then it's gonna show you what kind of environment already installed. You might probably see just a base. If this is the first time you're using that, I have another one here because I just created this morning just to test it out. But you should just see the base environment, and then you see the star. A star means this is right now the environment that's activated. That you are using this one, but we can switch environment. Just like here right now in this room, you can go to the other room, you activate another one. And also, within the star, you can check what packages have been installed within here. And there's another command here. Look at this one, conda list, or use pip list. Earlier we used conda env list. Env list is just check the environment. Conda list is for you to check the packages installed within the environment. So if you hit enter, then it's going to show you what package is already installed in the environment. And this gives you an idea. Sometimes if you want to install new packages, you can check the version, you can check all kind of stuff. So take a look at this. It's quite a long list, right? And here it shows you on the first column shows you the name, the second column shows you the version and the build, and also the channel. Because I installed it a long time ago, you probably see conda force or something. If this is the first time you're using it, the channel means the package is coming from IPI or coming from conda force. So it's going to show you up here and also show you the version. I think the most important one you want to check is the package name and also the version. Okay, so this shows you what's already in there. If you want to install some additional one, you might want to check it before you do something. Okay, so this is how you check the install packages. And it's the list is too long. You can press, I think, Control L to clean up. Not this one. Control S. I forgot what's this shortcut. On Linux is Control L. Oh yeah, maybe you can type CLS might be the command. CLS. Clear. So basically clear the screen. And there should be a shortcut. I don't use Windows frequently, so I forgot which one it is. But so next, let's create the environment. Like I said, the base environment, you don't want to mess up the base environment. Otherwise, you sometimes need to reinstall the package. So the next step I want to show you here on the left side, to create a new conda environment, you type conda create. So let me show you here, conda space create, and then -n. N stands for name. So basically you want to give your environment a name. So it's like in here, room 404, something like that. So you want to usually give, for example, GE. Specifically, we're going to, the name doesn't matter, but usually you want to give it short. Don't give a very long name because you need to type that every time. Conda activate the name. So you want to give it a short 2 to 3 characters, but no more than 5 or 6. Otherwise, it's too long. And then space type Python. So don't hit enter yet. Here, by default, if you just type Python and then hit enter, it's going to install the latest version. So right now, I think it's 3.11. So you're going to install the 3.11. If your environment requires a specific version, then you want to type equal. For example, 3.10. Okay, 1 equal sign. So this one, in this way, you can install a specific version. So you can actually 3.10, 3.9, 3.11, whichever you like. Although here I put just Python, I don't specify the version. It's fine. But my recommendation would be usually don't install the latest one, because some of the packages, especially when the package just released, a lot of the packages has not been migrated to the latest one, so it might not be compatible. It's usually safe to install one version below the latest one. So right now it's 3.10. You can 3.11. You can install 3.10. Okay. You can also try 3.8, but I would not recommend, because 3.8 will be deprecated in a couple years. Then you have to migrate. So 3.10, if you install 3.10 here, it's going to last you for a while. Okay, so if the package already are compatible with this one, then it's fine. So what I recommend here, conda create -n ge Python 3.10, hit enter, and this is specifically asking that we want to install 3.10. So now here, it's going to show you, okay, this new package is going to be installed. And if you see here, Python, and then scroll to the right, you see here, Python 3.10.12, right? So right, just like I said, the convention is 3 digits, 3 numbers, okay? Major, minor, patch. Okay, so right now the major version is 3, minor is 10.12. So I imagine I'm not sure how long they're going to introduce breaking changes to release Python 4 point something, but at least right now it's 3.10, 3.11, 12, something like that. Just hit enter, or you can type Y. If it is not responding, then it should just automatically download all the packages from the internet, and then install the environment, and that's it. So just like what this one is doing here is creating a virtual Conda environment. Okay. Once it's done, it also shows you the command here, how you can activate the environment. So think about, right? You have all the virtual environment. If you will need to use it, you need to actually activate it. So just like in this building, if you want to use a specific room, you need to get into the room, open it. Okay. So what we are doing here is just type conda activate ge, for example, whatever name that you chose. So conda activate ge, and then hit enter. Pay attention to the command line on the left side. Do you see it's changed right now to the environment? It's no longer parentheses space. It should be parentheses, whatever name you choose. In here, I'm using ge, so it's on the left side ge. So right now, you can do the same thing. I can just type conda list, and take a look at this. Right now, this is a much shorter list, right? It's no longer the long list I have in the basic environment. So that means right now, what you are doing here within this Conda environment, virtual environment, it's isolated, so it doesn't affect things outside. Okay. And you can create as many Conda environment as you want, as long as you don't use the same name. So right now it's just Conda, just the G environment. Again, you can just type conda env, and then list, env list. You should see right now the base and GE, for example. Also, you see the star. That means right now we are within this conda environment called GE. And within there, now we can install whatever packages that we want to install. And so next, let me show you how to install geemap. Like I said before, if you search geemap on conda first, and this is basically, this is the line of code that you can do. So conda install -c. C represents stand for channel. So it's going to install from conda first. If you don't have the C, by default it's going to coming from the Anaconda. I don't think geemap is in the Anaconda. So let me try out here just to show you. Okay, I can just type conda install geemap, hit enter. I've never used this before, but it's probably going to find it. If it is not available, it might switch to the conda first, but probably not. And this is something that you see, it's going to show you it's not available because these are the official conda channel. Basically, think about iPhone, all the apps by Apple. They have a specific server, for example, channel storing all the packages, and there's quality control. Other third-party packages are not there, so you won't be able to find it. So what we need to do is to add -c, and then conda first space, and specifically ask the package manager to get that one from conda first. So if you right now type, hit enter, it should be able to find it. Understand? So basically, like I said, 3 different locations where you can find packages: PiPi, Anaconda, and conda first. Most of the time, you want to just use conda first. So the packages, conda first has a large number of packages. Anaconda itself only has a limited number, so you only maintain some of the most popular one. but the packages usually are available both on Anaconda and also Conda Force. And look at this one, it's going to spin. The reason that's doing that is checking all the package version compatibility, because if you already the more packages you have already in the environment, the longer time it's going to take. So it's basically going to checking like all of you here. Think about here right now. I want to maybe buy some food for you guys. Okay, I cannot just buy some candy or peanuts or whatever. I need to ask you, what do you like to eat? What do you like to eat? Eventually come up with something that everyone can eat. Okay, otherwise you're gonna cause issues. So this is essentially what it's doing here. It's taking a long time, and this is so annoying. And this is why I show you the other way, that it's much faster, because geemap itself is not that big. It's sometimes take you a long time to figure out. Like basically, take you a while for you to ask, like then take notes and then ask, take notes, and then figure out, see if there's any compatibility issues. So if it's not working, if you're trying to install a package and then you take something like this, forget about it. Just Control C to interrupt and terminate the base drop. Yes, I enter. So there's a second way. It's going to be a lot faster. So it's called Mamba. So what we really want here is to install Mamba. So you can think about Mamba is a re-implementation of Conda, but it's much faster because it's based on C++, and it can basically resolve the much faster because it's more like doing parallel processing. Conda is more like sequence, RCU, okay, take nodes, RCU, take nodes, RCU, take nodes. But Mamba is more like simultaneously RCU all view and then figure it out and then resolve the issue. So you will see the differences. So now let me show you here. So what we want to do usually after you create a new Conda environment, you're just going to Conda install hyphen and then Conda first. You can copy paste the code, either one is fine, and then Mamba. And then later on, whatever things you use Conda to do, you can use Mamba. The first time it's doing here, it might be a little bit slow, but it should be much faster later. And you will see the differences. I don't know why Conda doesn't really solve the issue yet. But this is more like starting from a community package that people develop and then actually outperform the official Conda package. It's much faster. But again, right now we're still using Conda to install something, so it's a little bit slow, but it should be faster next time. And just be patient because the first time when you are installing this one, it also need to figure out the compatibility between the packages. And that's quite a little bit slow. And hopefully be done quickly. And the next line we here showing here, Mamba install geemap. Then basically you can use Mamba install to install any packages that you like. The last resort is if something is really slow, it doesn't work, then you can use pip to install. It's faster, but it doesn't make sure that it's compatible. Okay, just hit enter, install Mamba, and that's it. Then you should be able to install many packages very fast. And this is basically right now installing Mamba. Okay, should be done shortly. And if you're using the command prompt, you can use your up arrow key on your keyboard. So if you just type up arrow here, you see the Conda install, and then you can move. Oops, is it here? And then, or you can just type Mamba, whatever you like, whichever you prefer. So basically replace everything Mamba, Conda with Mamba, Mamba install, and then hit enter. And again, the first time is slow, but next time it will be much faster. So you see, it's basically searching all the repository, get all the package metadata, and figure out what they need. Then it's going to talk to the packages on the local computer, and then eventually figure out something that everyone is happy. Otherwise, if you're going to fight with each other and then it's not compatible, then some of the packages might be broken. But still, this is the first, I mean, it's a little time consuming when you are first installing it. But hopefully, it's be done in a couple of seconds, and then you can start using the packages And this is the same way that you want to repeat. Okay, so when you're doing a new project, sometimes if the new project requires a specific Python version, you create conda, create new environment, and then conda install mamba install whatever package you like. So in here, look at that. There are multiple channels in here, right? From conda first, from the Anaconda prompt, you see. So conda first. This is the third repository I introduced, and there's also another one here, pkgs. So this is basically the official Anaconda repository, but they don't have a whole lot. This one here, this two usually has the largest number. So not sure why it's so slow, but hopefully you'll be done in a couple seconds. Then you can see it's going to install. And this is the first time it's checking the first time, so the first time is slow, but you will have some cache on your computer, so it doesn't have to do that again when it's installing another packages. So this is one time only, but I think it's only checking every, I don't know the time interval, but it's only checking a couple hours or something like that. So because the package version doesn't change all the time, so you don't need to re-download them. Yeah, let's wait. And yeah, so this is pretty much all the commands we're going to introduce, and the last one is in remove. So if there's any specific environment that you are already done with that, you want to destroy it to save some space on your computer, then it's going to be conda remove, and then -n, the name, and then -- all. So basically you want to remove all the packages. So let me show you here. Oh, it's done. So now take a look, right? Geemap, and you should be able to see all the packages going to be installed, and these are all the dependencies. And if you scroll down all the way to the end, you see the package coming from conda first, and how big is each package, and what's the version, and scroll all the way to the end. So hopefully you see geemap 0.25.0, and it's going to install 243 packages. Because Python package is built on top of each other. Anytime you install something, it most likely going to install a bunch of others. So you see here, like 243 is pretty big, but 444 megabytes. So it's going to take some time to download. And once you're done, then you have the packages available. So let's let it finish, and I'll quickly show you here, like how do you remove a conda environment if you don't need any anymore, or if the environment is broken. So you can just use the command line to remove that. So unlike Windows, that you can just go to the program manager and then just click and install. All the conda stuff is through command line. There's no interface, so you cannot just open the GUI and then trying to edit the environment. Kind of slow here. It's might be because I'm recording the video, so sometimes it's using a lot of CPU. So once it's open it up, then just type conda remove, and then the name of your environment, and then remove all the packages. Of course, don't just remove the GE that we just created, because there's no point. But I can show you like conda env this. Again, you can, yes, still be slow. So conda, oops, env list. Again, you can show what environment is already there, then you can remove it. This is very slow. It's downloading and removing. Anyway, you can try it on a computer. Just copy the command and then paste it. You will need to confirm before you remove that. So just don't hit Y, otherwise you're going to remove the environment you just created. But keep that one. The nice thing is that once you have that working, you can install any additional package you like. So if you find any packages only conda first that you want to use, just mamba install -c conda first, and then the name. Optionally, you can specify version. So here I have another line here, geemap equal, again double equal. Okay, so don't forget. If you want to use a specific version, sometimes the latest version, if you break something, you want to use an older version, then just type the version number, so 0.225 or 0.24 something, but this is double equal. So compared to the Python version when we created, right, Python equal to 3.10, that one you only need one equal sign, but if you need to install other packages, you need double equal sign. So that's the differences between pip install, for example, geemap double equal sign equal to something. And okay, so like I say here, conda is also very stable. So conda remove sn. I just want to remove g and then o. Hit enter. It's still downloading, so it's going to take a while because it's 440 megabytes. So make sure that you wait until it's finished, and then you should have the environment ready. And on Wednesday, I'm going to show you how to actually to use that. Also, how to use that through Visual Studio Code and also Git. So after class, if you have time, you're welcome to just install Visual Studio Code and Git on your computer. And then starting on Wednesday, we can go through how we can actually open the IDE and then can start writing some code. Although it's not that complicated yet, we won't introduce how to deal with geemap yet, but just showing you how you basically you want to write Python code, how do you get started, and how do you get some source code from GitHub so that you can try it out. So here, if you go to GitHub, there are tons of packages available on GitHub. So now with that, you can, if the package is available on Anaconda or on PiPi, you can install it directly. If the package is not available, you can also install directly from GitHub. We right out of time, I will show you on Wednesday how you install anything from GitHub. So any repositories hosted on GitHub, if it is a Python package, but they also have not made that available on PiPi or Conda first, you can also install it directly using Git. So here, if you click this one, and this is, for example, the link, and then you can use this one. You can either clone the repository to your computer, and you can install it, or you can directly use Git to install. So we covered that on Wednesday. My computer is super slow right now. Yeah, so here, remove all the packages, and then you can just press Y, and then it's going to remove the environment. So this is how you create environment, install packages, and you can also update packages. Mamba update, and then the package name you can update. But usually you can install other packages, or you can install the latest version again. It will automatically update to the latest one. Okay, so it took 50 minutes to introduce a couple command lines, but in your daily work, it's going to take 10 seconds. And then done. You create a new one, and then you install packages. So it's going to super easy, but I want to make sure that you all understand the concepts, why we use Load Package Manager, how do you create the environment, how you install the packages. And this is very useful because you want to do that all the time when you're doing coding. And also, the other recommended way is, if you created this environment, you install all kind of packages, and you have to use it for a whole year. Sometimes I recommend just remove everything, create a new one, because sometimes if things get old, your computer gets very slow, and there are a lot of like unnecessary things in there. So just conda remove everything, and then conda create a new one again, and then just install. Then you have a fresh one. Everything works perfectly. So from time to time, you want to try that, but because otherwise, you never know what's already in there. What's working, what's not working. Okay, so that's all for today. I will see you on Wednesday. You can bring your computer if you want to follow me to install the software packages.